Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall. We built the pyramids, math, science, history, unraveling the mystery that all started with a big bang.
The title of this video is Scientific Notation. Scientific notation is used to make very large numbers and very small numbers more manageable. As two examples, the number of atoms in a penny is on the order of magnitude of 1 times 10 to the 24th. That's a 1 with 24 zeros after it, a very big number. The mass of an electron is on the order of magnitude of 1 times 10 to the negative 31st. That's a very small number of kilograms. A couple of things to make your life easier when you're using scientific notation. A positive exponent means that the number is big. It's at least bigger than 1. A negative exponent means the number is always small, or less than 1. Just keep that in mind. The first number in a number in scientific notation should always be less than 10. Put another way, there should only be one number to the left of the decimal. So here you can see 9.9, or the 9 is less than 10, and there's only one number to the left of the decimal. This number is wrong because there should only be one number to the left of the decimal, and because it's greater than 10. And this number on the bottom is actually the correct way to represent the wrong one. Move the decimal over one more place, so the 5 changes into a 6, and now the first number is less than 10, and it only has one number to the left of the decimal. Let's do some practicing. The number 26,000. Well, that's a big number. It should have a positive exponent. Which positive exponent? Well, there's an implied decimal here. In fact, we won't make it implied anymore. There it is. We need to know how many places to move it to the left so that the first number is less than 10. Well, we're going to move it 3 places to get around the zeros, and then 1 place to get around the 6. That's 4 places. So this number is 2.6 times 10 to the 4th. And we'll make that an exponent. It's a positive exponent again because 26,000 is a big number. Literally, this number is a mathematic calculation. It's 2.6 times 10 times 10 times 10 times 10. Or 10 times itself 4 times. Put another way, it's 2.6 times 10,000. And obviously, if you took 2.6 times 10,000, you'd get 26,000, the number you started with. So when you put a number in scientific notation in your calculator, at least when you do it using the caret button, you're telling the calculator to do a calculation. Now, a small number. This number is a small number. Perhaps it's the weight of an eyelash in grams. Well, how many places do we have to move the decimal to the right to get the first number where it's supposed to be, or the decimal where it's supposed to be? Well, to get around the zeros, you have to move 4 places. And then to get around the 1, another place. So this is going to be 1.34 times 10 to the negative 5th. Now, why negative? Because this number is small. And 1.34 is less than 10. I only have one number to the left of the decimal. That works. What does this number literally mean to the calculator? Well, it's 1.34 times 1/10 5 times. Or 1.34 times 1/100,000th. Let's see if that works. Well, this is the 10th place, 100th, 1000th, 10,000th, 100,000th. The 1 is in the 100,000th place. So this is 1.34 times 10 to the 100,000th.
Since the dawn of man is really not that long, as every galaxy was formed in less time than it takes to sing this song. A fraction of a second and the elements were made. The bipeds stood up straight, the dinosaurs all met their fate. They tried to leave but they were late and they all died. They closed their asses off. The oceans of Pangea, see you wouldn't want to be set in motion by the same Big Bang. It all started with a big